Hello there. Hope this finds you well. We are going to look at a little process called polynomial division. And one of the first things that I wanted to say about polynomial division is that it is actually very similar in the mechanics or the process like regular long division with numbers. Okay? And that is to say that it's kind of tedious. It's an iterative process or a repetitious process. You do the same thing over and over again until you're done. And so let's kind of review the mechanics of long division first with just a numerical example like 218 divided by 13. Okay, so the first thing that you would probably do in long division is you would set that up with a little box like that. 218 is the dividend, that goes on the inside, and 13 is the divisor, that goes on the outside. So now, what do? We say 13 goes into 218. No, we just look at 13 and 21, just the first two numbers. Okay, so you look at that and think, how many times does that go in? Well, that's pretty easy. It only goes in once. So now we take that 1 up there that we just figured out and we multiply 13 and write it down below the 21. Okay, then we subtract. And 21 minus 13 is 8, and you bring down the next 8 from the 218 out of the dividend, and now you're ready to do it all over again. The process starts over. So we look at 13 and 88 now. How many times does 13 go into 88? It happens to go 6 times. 6 times 13 is 78. So you write that down below, and you then subtract, and you end up with 10. Now, 10 is the remainder. So we are done with the dividing. 218 divided by 13 equals 16 with a remainder of 10. Now you might have been expecting me to add a decimal point and then some zeros and start bringing down zeros and keep on going and going and going. In this case, we would go a very, very long time before we finally gave up. And that is something that you learned a little bit later on. When you first learned this long division process, this is where you stopped. You stopped with the number on top, and then you used the number that you got at the end as the remainder. That's what we're going to do with polynomial division. We want to know what the quotient is and what the remainder is. In our first numerical example here, 16 was the quotient and 10 was the remainder. Okay, so let's keep that in mind as we take a look now at an example with actual polynomials. So I'll have a dividend, x squared plus 5x minus 4, divided by x minus 3 as the divisor. So that goes on the outside, the dividend goes on the inside, and I begin the process. First thing, which is a little bit different here, is I'm only going to look at the x and the x squared. I'm not going to look at the minus 3 or the 5x or the negative 4 or any of that just yet. First, x goes into x squared how many times? That would be x times. Okay? Now I take that x up on top and I multiply. X squared minus 3x is what I get from multiplying. And I'm going to subtract just like I did before. And be careful here, 5x minus negative 3x is 8x. This is where polynomial division gets treacherous, okay? Subtracting stuff, it's easy to make a mistake and forget about subtracting negatives and things like that. So 8x is what I get, then I bring down the minus 4, and I'm all ready to start over again. Once again, I'm only going to look at the x and the 8x now, the leading terms of those polynomials. So x goes into 8x 8 times. That was pretty easy. Now I take the 8, multiply, and I get 8x minus 24. Okay, good enough. Then I'm going to subtract that. And be careful once again, negative 4 minus negative 24 is positive 20. And now I just have a number. No more x's, and I'm done with the dividing. So I will just state the quotient and remainder. X plus 8 is the quotient. 20 is the remainder. Okay? All right, so that's the process there. It just kind of happens over and over again, and you just kind of have to steel yourself and get ready to do a multi-step little process here. Okay? Keep your arithmetic chops finely tuned, and you won't make silly mistakes. All right, let's try another example. I'll show you one of the little pitfalls that may come up on your next problem. So I'm going to try this one. This is a pretty hairy looking problem here, and I'm writing it as a fraction this time. Dividing is, that's what fractions are, is one thing divided by another, so that's okay. You may see the problems posed as a fraction. That's okay. So we write it then as a division problem, and I want you to look at that dividend very carefully. The top of the fraction, which of course is the dividend, goes x to the fourth plus 3x squared, and then it has the minus 5x and the plus 10. There's no cubic term. There's no term with an exponent of 3. So make that observation when you're setting up these problems, because if a term is skipped like this one did, you need to add a little placeholder for that exponent value. You'll see why in just a second. But it's possible that it may not actually affect your result depending on what you're dividing by. But in this case it will. I just wanted to show you that. Okay, so there's our divisor on the outside. We do the same routine. I'm going to just look at x squared and x to the fourth. How many times does it go in? It goes in x squared times. I take the x squared and I multiply. Then I subtract. And you can see now where that 0x cubed is going to come in handy, right there. 0 minus negative 2 is positive 2. So that gives me 2x cubed, and I bring down the 3x squared from the dividend, and now I'm ready to start all over again. X squared going into 2x cubed goes in 2x times. And so I multiply the 2x up there on the quotient times that divisor. It gives me 2x cubed minus 4x squared. I subtract, and I get 7x squared. 3 minus negative 4 is 7. I bring down the negative 5x. Ready to go again, one more time. So I'm looking up there, and I see that x squared goes into 7x squared 7 times. I write that, multiply, 7x squared minus 14x. I subtract, and I've got my 9x plus 10 down there. That is the remainder. It's a lower degree polynomial than my divisor. So that's the remainder. I'm done. The quotient up there on top, x squared plus 2x plus 7, and the remainder is 9x plus 10. And that's all I really want to focus on here in this little video, is how you perform the process and recognize what you got at the end. Okay? All right, that's it. That's enough, I think. And I will see you soon. Take care.